So, welcome to Workshop Wednesdays. My name is Megan. I'm the marketing manager here at Monolith Forensics. If you haven't been to a Workshop Wednesday before, basically what we do is every 2 weeks, we cover a different digital forensics topic, just kind of free content, free educational content for you guys, just to keep learning stuff. So we will have time for Q&A. For Workshop Wednesdays, we do actually invite you to come on stage and ask questions. So if you're comfortable asking your question over a microphone, when we get to the Q&A, you can raise your hand and I'll give you permission to do that. Or you're welcome to put your questions right in the webinar chat. I think that is it for my spiel. So I'm going to go hand things over to Matt and I'll come back for the Q&A portion.
Great. Thanks, Megan. Good morning, everybody. Again, I'll do my quick introduction here and then we'll get started. My name is Matt Danner. I am the CEO of Monolith Forensics. And so my full-time day job is I run Monolith. And if you're not familiar, I'm looking at the attendees here. It looks like most of you guys are either customers or familiar with us. But at Monolith Forensics, we have one commercial product that we sell. It's called Monolith. It's a lab management and sort of case evidence documentation report analysis management system that's used to help forensic teams run their digital forensics labs. So if you are in a team like that and you have a need for something like that, just hop over to the website, take a look, and reach out to us and let us know if it's something you want to try out or something you want to get some more information about and get you a trial and a demo and all that good stuff. So at these Workshop Wednesdays, what I try to do every 2 weeks is I try to put together some kind of practical demonstration or talk related to forensics to hopefully expose you guys to something that maybe you haven't seen before or a concept you haven't heard of or played with yourself, and basically give you a little bit of a little taste of some practical concept related to forensics and see if it's something you can investigate further on your own or make use of on your own. So we do these every 2 weeks. Sometimes we have guests that come on and do presentations, but most of the time it's just me. So today what we're going to talk about is a very long-standing tool in forensics, something called Log2Timeline, also called Plazo. If you've ever taken SANS training or been through SANS training, this is a tool that they typically use a lot, especially in their SANSIP workstation. And all that stuff. So some of you may be familiar with it. In other presentations, I've talked about Log2Timeline, where I've mentioned it in passing in relation to Docker, where I've given some Docker presentations in the past just explaining its usefulness in forensics. And I figured I've mentioned it enough times where I should probably just do an actual demonstration of what I've been talking about this whole time. So what we're going to talk about is we're going to talk about Log2Timeline, and we're also going to talk about using it as a Docker container. And the purpose is just to show how, in my opinion, a Dockerized version of Log2Timeline just makes using it a lot easier. Because I think traditionally in SANS, what they would do is they would have you get the SANSIP workstation, which is basically a heavy virtual machine that you would run on a laptop or workstation, and you do everything inside that VM. And I think with Docker, you can effectively get the same effect by just using Docker on any system that you're using without having the need for a large virtual machine management system like VMware or VirtualBox or anything like that. And you don't need these big, massive virtual machine images to do the work. So just to get started, I'm going to share my screen. I'm going to walk through some of the basics of Docker really quick, or at least installing Docker. So what you're seeing here, this is just my my Chrome browser, and we're on something called Docker Hub. And Docker Hub is where people that build Docker images, they make those images and then they host them on Docker Hub. Docker Hub is just a repository for Docker images. There are other repositories out there, but Docker Hub is sort of the primary one that's associated with Docker itself. If you want to install Docker, there's a few different ways. You can install Docker on pretty much any operating system. And here's sort of a support matrix for different OSs that have Windows. That can install Docker. Docker is primarily built to run on Linux or Unix-based systems. So its happy place to live is something like Ubuntu Server. That's kind of like, a really solid bulletproof method of deploying Docker, but that's not always the most practical use case for forensic folks. So if you're running on Windows or Mac OS, then what you want to go with is the Docker desktop installation. So Docker desktop is basically just a desktop client that installs the Docker service and then gives you a nice user interface to interact with Docker. I am currently on a Mac OS system, so I'm running Docker desktop on this Mac OS system. I also have Windows systems as well, where I run Docker desktop also. The key thing to keep in mind with Docker desktop and Docker in general on Windows is that you typically also need to install something called WSL2 on Windows. And what that is, it's Windows subsystem for Linux. And basically what it is, it's just installing drivers in a backend Linux subsystem so that Linux-based containers can run on Windows within Docker. So that's pretty much it. And usually when you install Docker on Windows, like the first option it gives you in the install dialog is to install WSL2 if it's not already installed. And it's pretty cool because once you install WSL, if you kind of explore Windows after that, you'll sometimes see a little penguin icon called Linux or Ubuntu. And if you click on that and run it, you'll get this interesting little Ubuntu shell that opens up because it's basically a Linux subsystem that's running on Windows, which is pretty cool. So that actually is not just related to Docker, it's also related to other Linux flavored things you can actually do on Windows. And that was part of a few years ago, Microsoft tried to make this push to make Windows a more robust development machine for software development teams, where Mac OS is usually the preferred developer OS. So Microsoft was trying to close that gap a little bit. So because everybody hates using the PowerShell and command line interface for command prompt on Windows, everybody likes that Unix style, Bash style flavored terminal system. So Microsoft tried to close the gap by creating this Windows subsystem for Linux system so that you can get that Bash style interface and workflow on Windows. Anyway, so that's the thing to keep in mind. If you install Docker Desktop on Windows, just make sure you install the WSL2 if it's not already installed. That way you can run Linux containers, which is important because if you want to run this Log2Timeline Docker container on Windows, this is a Linux container. So in order to get it to work on Windows, you need to install the WSL2 subsystem. Okay. So quick summary, if you want to run Docker on Windows, install Docker Desktop. If you want to run on Mac OS, install Docker Desktop. If you want to run it on Ubuntu, well, you can install the Docker service directly onto Ubuntu without Docker Desktop, which is actually its kind of more native environment. That's where it likes to live. Okay, so back to Docker Hub. So again, what we're looking at here is this is the details page for the Log2Timeline /Plazo Docker image. I don't know. I assume this is the official Docker image. I don't know if some brave volunteer put this together and hosted it, but it gives you some brief information here about what this image is. What's important to know, it is a Python-based image, Python-based engine. So what that means, all the code that makes up Log2Timeline is written in Python, and it's open source. So you can go find the GitHub repo and actually look at the code and everything. And lots of people have contributed to it over the years. If you're not familiar with what Log2Timeline is, basically it's just a giant open source parsing system for forensic artifacts, where you can basically, the goal of this system was to just try to build an open source parsing system that just parses anything and everything you could possibly think of to parse on a computer or forensic system or digital system that you're trying to analyze. And what it produces is something called a Plazo file, which is just it's basically just a sort of specific file structure that stores the output of all the data that's parsed. And the goal is it parses out all these forensic artifacts and just plots them onto a master singular timeline. So if you point this at a Windows forensic image, it will produce a Plazo file that is effectively just a linear timeline of every single event that it can parse out of a system. That could be everything from event logs, MFT, file system records, uh, file system event logs on Mac OS, the link file data, jump list file data, registry information, file system metadata, file metadata. Basically, anything and everything that has a timestamp will get parsed by the system and placed on a giant timeline. And so what it produces is it produces this Plazo file output, which by itself you really can't do anything with. It's just basically a storage format for the parsed data that it produces. And then there are other utilities associated with Log2Timeline that you use to then parse data out of that Plazo file. Usually what you do is you'll use something like psort.py or whatever to parse data out of the Plazo file to produce a CSV document. And then you use that CSV data to actually do your review. Typically, what can happen is if you take Log2Timeline and you parse like a full like Windows forensic image, you'll usually end up with a giant Plazo file. And you can produce that entire Plazo file as a CSV, but typically you're going to end up with millions and millions of records. So that CSV file is not going to be very useful because you're not going to be able to open it in anything, or Excel is going to choke when you try to open it. So typically what you do is you use these other utilities that come along with the Log2Timeline system to basically extract specific things, specific data sets out of that Plazo file that you want to produce like smaller CSV file data sets that you can actually review. And then from there, once you get that data, just to relate back to some of my other presentations, I would suggest doing something like, let's say you do end up with a lot of data, you end up with a CSV that has millions of records. That's where I would consider maybe dumping that into a SQLite database, into a SQLite file, or even using something like MySQL, dumping all that data into MySQL, and then using the powerful query syntax and indexing process of something like MySQL or Postgres to actually go through that data. That way you don't have to constantly run a bunch of different psort commands against that Plazo data to get what you want. Okay. So let's see here. So what I want to do now is I'm going to switch over to my trusty VS Code platform here. Give me a second here. Let me make sure I pull it up correctly. Okay. So what I've got here is I've put together some reference docs related to Plazo and Docker. And let me pull this up and I'll try to zoom in just a little bit. Close that out. I don't think I need that anymore. So I'll share this, but this is just basically a generic Plazo Docker reference. The one problem with Log2Timeline is the documentation for this platform kind of sucks. This is if you've never used this before, this is an incredibly useful tool to use and learn how to use. But unfortunately, the documentation around this system is pretty bad. So it's kind of hard to learn how to use it, especially with Docker. It's kind of difficult because they don't have a whole lot of documentation on how to use it in a Docker. So what I've done is I put this document together that kind of gives you the layout and the rundown of how to use the system. So what you have here is if you have Docker installed on your system, with whether it's Mac OS, Windows, or Ubuntu, or whatever, the first thing to do is just pull the Docker image. So Docker pull Log2Timeline/Plazo. And this will pull that image from Docker Hub that I just showed you. And that will download it. I think it's about a gig in size. And once you have that image downloaded, you can now run that image in Docker as a container. So if you've been to some of my previous webinars, I've talked a little bit and explained what Docker is and its different components and how it works. So what we're doing here is we're downloading the image, which is kind of like the blueprint. And then from that image, we can then run containers with it, which the containers are sort of the houses that we would build from the blueprint. Okay. And then it's giving you a little extra info here where if you want to pull a specific version of Plazo, you can add this syntax to the end here, this colon. And what this is called a Docker image tag. So the developers, when they push new images up, they'll usually create a latest version, which is this. And then they'll create a tagged version so that you can go back and pull specific versions of the image if you want. If you don't want to use the latest, you can then go back to a previous version if you're comfortable with it. And then down here, we have some just the different Docker run commands to kind of educate you on what these commands are, how to use them. You can do things like constrain the amount of resource usage on your system that you can that it will use and that sort of thing. And then there's some log2Timeline options here as well. So log2Timeline is pretty smart. You can basically just point it at any file or set of files, and it will try its best to figure out on its own what that file is and how to parse it. But the more log2Timeline works best when you're very specific with the options that you pass to it. So if you know that you're parsing a specific type of file, just try to tell log2Timeline that that's what that file is. That way it doesn't have to waste time figuring out exactly what the file is and maybe run a bunch of unnecessary parsers against it, and you might get more unreliable results. If you're running it against a raw forensic image or an EO1 image, you can pass all those options into it so that it knows exactly what it is. Okay, this is one of those things I would strongly recommend just researching, looking through all the different options. And what's great about this is once you understand this stuff, you can pre-create different log2Timeline run commands and just save them in bash files or save them in a markdown file for documentation purposes. And that way you just copy and paste and use them anytime you want. Then we have psort options. So the psort utility, this is the utility that you use to actually parse the Plazo files that get generated from log2Timeline. So once you have this Plazo file, you now need to somehow get the data out of it for review or analysis, and that's where this psort system comes into play. And this is how you then parse that Plazo and then export it to your format of choice. You can see here there's things like there's a CSV, there's Excel document, there's different JSON formats. So you can output this to multiple different formats depending on your use case or your needs. Okay, and then here are some example Docker run commands. These look pretty nasty, but I'm going to walk you through these in a second so you understand what these are actually doing. Usually you're going to run 2 Docker commands. The first command is going to actually parse the data that you're trying to parse and produce the Plazo output. The second command is going to be the psort command, where you're going to run that psort to extract or parse data out of that Plazo so you can actually review what you want. And you can kind of see that here where it's passing in a specific date range to get specific data out of that Plazo file. And then there's a pinfo, which does a little bit more metadata information about the Plazo stuff. Okay. So that's the basic information here. This is also a great place to use AI, where AI knows log2Timeline pretty well. So if you're trying to do something very specific with log2Timeline, just open up Claude or ChatGPT and start talking to it and asking it, hey, here's some stuff I'm trying to do. How do I do this? How do I use log2Timeline with this particular file or this particular type of file or whatever, or set of files? And it will give you the commands. And you can just tell, hey, I'm running this as a Docker image. How do I run this? And it will easily help you put that stuff together. Okay, so here, this file here is, and hopefully everybody can see this. So Megan, let me know if the text is too small. So this is a couple of the example commands that we're about to run, just so I can demonstrate how this system works. And what you're seeing here, this is an entire log2Timeline command. I know it looks nasty. I know it looks really complicated and long, but it's really not that bad. It's not as bad as you think. And so this is a command we're about to run here in a minute so I can demonstrate how it works. And I put this examples document together to give you guys a reference to explain exactly what this command is doing. And so I'll walk through the breakdown really quick just so that you guys understand what this is. The first command here is Docker run. This is just the Docker command that we're telling the Docker service, hey, I want you to run an image and start up a container, okay? So here it's saying, just like I just said, it starts a one-time container from an image, okay? This second line here, this platform, Linux, AMD 64, this is really important because while there is a log2Timeline Docker image on Docker Hub, they do not have an ARM build for log2Timeline. So what that means is whenever you construct a Docker image, you basically can define what CPU architecture that image is based on. So it's no different than if you compiled a binary and executable to run. You have to, at the time that you build or compile some software, you have to tell the compiler what architecture or operating system you're compiling for. That's why on Windows you have .exe files like executables, and then on Mac OS you have binary files that are a different format. And same thing with Linux, you have package files or whatever. Um, in this case, you have a similar problem where when you build a Docker image, you have to define, okay, what architecture, what host platform is this image being built for? And there are specific ways you can do it. Typically, by default, when you build a Docker image, it's just going to adopt whatever the host system is. So if you're building a Docker image on an ARM system like this Silicon Mac, it's going to make an ARM-based image. If you build a Docker image on an Intel-based system, like an Intel-based Windows system, it's going to build an 8664 image, AMD-based image. Okay. So the tricky part is I'm on a Silicon Mac, which is an ARM processor. So if I want to run this AMD 64 Log2Timeline image, I could do that on Mac OS. Mac OS has a virtualization system to do that, but I have to tell Docker that's what I want to do. Otherwise, you're going to get an error that this isn't the right image architecture or whatever. So by passing in this argument, I'm just telling Docker, hey, just FYI, I want you to run this as an AMD 64 image. Like I know we're on an ARM system, but go ahead and run it as AMD 64. And then Mac OS will take care of the rest and actually run it properly. Okay, so that way, with Log2Timeline and other Docker images like this that you're working with, if it is an AMD 64 based image and you're on a Silicon Mac, that's okay. Just pass in this flag and it will run just fine on your system. Okay. This --rm command here, it's going to delete the container after the command exits. This is nice because if you don't do this, you could potentially just end up building up a bunch of wasted disk space on your system. So this is basically just a cleanup command. Log2Timeline is not like a server that's going to run indefinitely. This is just a binary, basically a piece of software that we're just going to run as one process, and then when it's done, it's done. So we want to do some cleanup, and we don't want to like leave any traces or remnants behind. It's just going to collect garbage on our system. This command here, this --user command, this is basically saying it's telling the container, hey, container, run this process as the current host user and group so created files are not owned by the root. So this can just cause some weird, if you don't do this can cause some weird file permission issues within the Linux container that this runs in. So by passing this in, it just ensures that permissions are set properly for files that get created or accessed by the container once it's running. This command here, this dash, now this looks like alien language, but this is a specific Docker argument where we're basically mounting a directory in the container. So if we have our forensic evidence that we want to parse with Log2Timeline, we need to tell the container where that evidence is and where it lives. Right now, it lives on your host system. So you need to tell Docker, hey, I want you to mount this location so that the container has access to it. So -v is really just a short name for volume. So it stands for volume in Docker. And we're telling it, hey, mount the current location that we're running this from and mount it into the in folder as read-only inside the container. So the way that the guys set up this Docker image, inside the Docker image container, there is a folder called in at the root location. In that in folder, that's basically the mount path that it's saying. They are saying, hey, you should put the evidence you want to parse into this in folder. And that's where we're going to set sort of the semantic, default for where evidence should end up going. Because when you make this mount, what's happening is it just creates a virtual, almost like a symbolic link between the location on your host system and a location inside the container. So when that container runs, from inside the container's perspective, when it looks at this in folder, it's going to see whatever data you have in that local mounted location on your host system. Okay. Same deal here. What we're doing is we're defining an output location. So when it produces a Plazo file, it needs to put the result somewhere. And we don't want the result to be stored in the container because we're just going to lose it when this remove command happens. We want that output, that Plazo file, to end up on our host system so that we can do more stuff with it. So again, all we're doing here is we're telling Docker, hey, I want you to mount my local output folder on my Mac OS system and mount it to the out folder that's inside the container. So what that means is when the container runs and that Python, that Log2Timeline process runs, it's going to put its results in its out folder, which is going to show up in our output folder on our local system. And that way, when the container gets destroyed, That's great. It doesn't matter because our output, the Plazo file we generated, is going to be inside of our local output folder on the host system. This command here, log2timeline/Plazo, which is right here, this is the part of the command that actually tells Docker which image we're trying to run. So we're just identifying as log2timeline/Plazo. And if we go back to our Docker reference, you'll see when we made that Docker pull, this is the Docker command to pull an image, and this is the image identifier. So this is the name of the image, log2timeline/Plazo. Okay, and then we're just doing the same thing here by telling Docker, when we say Docker run, we're referring to this image. Okay. And then we also say log2timeline because this is what once we're in the container, we're now invoking the log2timeline command. So once the container is running, we're now passing the container the command that we want it to run, which is this log2timeline command. And then everything else after this is just standard log2timeline parlance. So we're just giving it all the same arguments that if you're used to using log2timeline directly, everything after this point is just all log2timeline arguments. And we're showing it here. In this case, the demonstration I'm going to do is I'm going to show how to parse an MFT file using log2timeline. So what we're doing is I'm telling log2timeline, hey, only use the MFT parser. I'm doing this because I know the file that I want to parse is an MFT, so I don't want log2timeline to waste time running a bunch of other random parsers that I know are not going to result in anything. So I'm just telling it right up front, hey, run the MFT parser. The next argument here is I'm telling it what kind of storage file to generate and where to put it. So I'm telling it, hey, generate a Plazo file called mft.plazo and put it inside your out folder. And again, this out folder, in this previous command here, we've mounted it to our local output folder. So what this is going to happen is when it generates this Plazo file, it's actually just going to end up inside of our local output folder on our host system. And then the very last command here is just telling it what file to actually parse. So you'll see here we've got a /n/ntfs-test $MFT. So what's happening here is because we already did this volume mount here, what's happening is inside the container, when log2timeline looks at its own in folder, it's going to see whatever we have mounted to that folder at the previous Docker command. So in this case, we're just mounting the local directory, which is everything that you see here on the left. And then we're telling it to parse the ntfs-test/MFT file, which you can see over here on the left. I've got an ntfs/test, and there's an an MFT file in there. So when I run this command, inside the container, it's going to check this in folder. And what it's going to see inside that in folder, it's going to see all this stuff. And then it's going to go into this ntfs test folder, and then it's going to find and parse this MFT. Now, I have two test MFTs here. I have one that's this NTF test, and then I have this Wharf workstation MFT. So all I have to do is I just have to change this argument right here to point at whichever MFT I want it to parse. And to give you an idea here, I'm going to open up my Finder window really quick. And I'm doing this because I want you to see some of the file system information really quick before we do the final run here. Give me just a second. Okay, so this is the actual Finder window, so you can actually see some of the file system metadata. I have already done 2 runs of this before this because I wanted to make sure I had results set before we did this in case something goes wrong with the live run. So I've already got 2 output folders because I've run log2timeline against both this MFT and this MFT. And so this output here, this is the output from the NTFS test MFT, which basically I created a virtual disk on Windows and just created a blank NTFS volume, threw some random files on it. And that created a very, very small MFT. And I did that on purpose so that I could run and generate a Plazo file that was relatively small and a CSV file that was like relatively small. So I could actually open it and demonstrate what it looks like. But I also exported the MFT off of one of my Windows workstations. And you can see this MFT is 3 gigabytes in size. Okay. And I ran log2timeline against it using Docker, and that generated a nearly 9 gigabyte Plazo file. So this Plazo file has 9 gigabytes worth of MFT data. And if I were to generate, I could convert this Plazo to a CSV, but it would generate a gigantic CSV file with probably, I think, about 3 million events in it, which would make that CSV pretty much useless. What I would really want to do here is either convert it to a JSON, or I can convert it to a CSV and then basically dump that CSV into a database of some kind, or use psort to then just filter down to certain specific date ranges so I could get those 3 million events down to something more reasonable that can actually open up in an Excel. But this is the result. If we look at our output for the NTFS test, the smaller one, you can see our Plazo result was only 260 kilobytes and our CSV was 200 kilobytes. And I'm going to open this up really quick and share this so you guys can see what the result actually looks like. So give me just a moment here. And then what we'll do is I'm going to show some of this and then we'll end the session with actually running some of these commands so you can see it actually run in action. So this is the output. This is what you get. I'm going to zoom in a little bit here so you guys can see it. If you're used to Log2Timeline, this is probably nothing new. You've probably seen this before, but you basically get all this rich information here. And the most important thing is you get these timestamp values. And you're also getting this column that's really nice because it's basically modified access created and birth time, which birth time is something unique to Unix or Linux-based systems. But basically, it's just plotting, it's parsing this MFT, it's going through every single MFT record and parsing out every single timestamp that the MFT can store. And if you're familiar with MFTs and NTFS, it can store up to 12 timestamps, I believe. So if you've got a system, this is a fairly small NTFS. I think there's only maybe a handful of files in this volume. And just from one MFT, from that small amount of files, it produced 426 records that span all these different timestamp values. And as you get through here, you can kind of go through these different columns here. And some of these columns have more information than others. So here, you're seeing it's telling you things like, okay, this is a timestamp that parsed from the standard information attribute of the MFT file. And then it's telling you the actual file name and path of the file that this MFT was referencing, which is this system volume information / WP settings.dat. And as you go through, you'll see more and more information. Here's more attribute data with some hash information, and it just kind of goes from there. And at the top, we can see the column headings that we're going to get. We've got some extra information, which I assume is just a place where they put just additional data that they're parsing. Format is MFT. You'll see this format change depending on the data that you're parsing. And then you've got the file name itself. You got a description column and all kinds of stuff. So this is what the output looks like for parsing an MFT file. If you parse a more varied assortment of artifact files, you'll get a lot more varied data. You'll see link file artifacts. It'll parse out web history. It'll parse out just all kinds of log data, like event logs and things like that. So what I'm also going to do really quick is I'm going to switch over to. So this is my command terminal, and before this webinar started, I actually ran Log2Timeline in Docker against that larger MFT that's from one of my workstations. And I wanted to show this because this just shows the output of like how long it took and what it actually created. So here's the source path. So this is that Wharf workstation MFT. That's that MFT that's about 3 gigs in size. It took about 25 minutes to run. And it parsed out, let's see. Yeah, so if you look at this, it parsed out 30 million events. So that was just one MFT file. It's for a workstation that I've had for years. I've done all kinds of stuff with it. And out of that one MFT file, it was able to parse out 30 million records. That's a lot of data. That's a lot of data. So that's not data that you're going to, and this is what resulted in that 9 gigabyte Plazo file. So you're not going to take this data, convert it to a CSV, and start going through it. That's just not realistic. So that's where that psort utility within Log2Timeline is going to come in real handy, because you can take that psort and pass in some date range parameters and some other parameters and basically get an export, a JSON or CSV export or Excel spec export of a subset of that data that you can actually review. The other option is to do a full export of this data into something like a CSV or JSON, and then dump it into a database and then use the power of databases to actually run queries, build indexes and things like that. So you can actually look at all this data at once. But basically you're not, the strategy is not to then convert this to CSV and review it. You need some more data oriented strategy for going through this data. But I wanted to show this just to give you an idea of how long this took. This took 25 minutes. I think by default, I think it just uses one processor. It took 25 minutes to parse an MFT file this is probably a more standard result that you would get from any heavily used workstation or computer that you're parsing an MFT file for. So imagine what I would get if I just parsed the entire, if I had a forensic image of this workstation, and I just parsed the entire forensic image with like no filtering or limiting or parser selection or anything. I mean, it would probably produce a 100 gigabyte Plazo file with 100 million plus records in it, right? Okay. So what I'm going to do now is I'm going to run, just so you guys can see it, and then we'll kind of wrap this up. I'm going to run my Docker command against, so here's the Docker command just to run Log2Timeline against that small test MFT. And I'm going to run this just so you guys can see what it looks like and see like how long it takes and what that process looks like. And so I'm running it now. You can see we get a little bit of an output. And because this MFT is so small, it only took a second to parse. So it didn't take very long at all. And then I'm going to run, and that generates the Plazo file. And then the next thing I'm going to do is I'm going to parse that Plazo file and just convert it to a CSV. And that CSV that it generates is the same one we just opened and reviewed a second ago. So now I'm generating the CSV. It's going to give you a little bit of a warning. It's telling you that Log2Timeline CSV has some timestamp limitations that you should be aware of, which is great. Just be aware of that. And it'll take a couple of seconds to produce that CSV. Okay, we're already done. It has 832 total events, which is great. And now we've produced that output. So if I do just here in the command line, if I do ls command, you can see what I've done is I put some underscores underneath the other output folders for the previous runs. And so this current run generated this output. So what I can do is I'll cd into that output folder, run an ls command. And you can see we generated our Plazo file, which was about 262 kilobytes. And then we have our CSV that it generated, which is about 204 kilobytes. And that CSV is going to be identical to the one that we just showed you a minute ago. But basically, it's that simple. This is an example of just running it against a single MFT file. But like I said, you can run this against a full-blown forensic image. You can also run it against, let's say you have a full forensic image, but you don't want to run Log2Timeline against the image. What you can do is open that image up in like FTK Imager or Xways and do a selected export of artifacts from that image. Like you could export the link files, registry files, jump lists, MFT, event logs, and other standard artifacts, and just export those into like a zip package. And then you can point Log2Timeline at that zip package and have it parse those artifacts instead of parsing an entire forensic image. And then you get this nice timeline output that you can then start going through. And that'll be a lot faster, more efficient, and won't produce as much noise as if you just run it against an entire forensic image. So I'd highly recommend, if you haven't used Log2Timeline before, I'd highly recommend looking at it. It's basically sort of, if any of you have used Cape before, Log2Timeline is kind of like Cape, where it kind of produces the same type of results. But this existed long before Cape did. This is what we used to use back in the day. So I think it's still used a lot today, but really convenient. It's now even more convenient with Docker. The most important thing I forgot to mention, I mentioned before, the reason it's so important that this is on Docker is because years and years ago, at some point, the folks that manage and develop Log2Timeline, they stopped making Windows binary builds of Log2Timeline. So you cannot run Log2Timeline as an executable on Windows anymore. The reason for that was they started using they built some parsers that require some libraries or packages that only exist on Unix-based systems and don't exist on Windows. So they couldn't make compiled versions of Log2Timeline for Windows anymore. So they just stopped doing it. But this solves that entire problem because you can install Docker Desktop with WSL and then run Log2Timeline exactly the way I just showed you here, except on a Windows system instead of Mac OS. So that makes Log2Timeline kind of a valuable tool again, because I know in forensics, we're all using Windows computers for the most part. That's what most of our tools are based on. So with this Docker system, you can now bring and add Log2Timeline to your tool set on your Windows workstations. Okay, so I'll wrap it up there, and I'm going to share these files with Megan, and we'll make sure you guys get these markdown files so that you can use them and reference them. But realistically, you could just as easily just ask Claude or ChatGPT to compile your own set of notes and documentation for Log2Timeline. It'll work just as well. So that's what I would actually recommend, is using AI to help you construct these different command line runs for Docker, so that you don't have to reverse engineer it every time. It'll pretty much nail it if you ask it. But okay, I'll pause there and see if there's see if you guys have any questions or anything you'd like to comment on or ask questions about.
Great, cool. If anybody has a question or comment and you want to come on microphone and ask that live, go ahead and raise your hand and I'll give you permission to do that. Or if you prefer, drop it in the chat and we'll go through the questions in the chat as well. Derek is asking if we can share a link to the GitHub repo.
Yep, I'm getting it right now. There's the GitHub repo, and keep in mind there's two repos here. There's the GitHub repo, which is the source code, and there's the Docker Hub repo, which is the Docker image. So I've just posted a link to both of them there. Oh wait, that's the hosted panelists. Oops, let me post it to. Oh, I guess I can't post it to everybody. Megan, can you make sure those two links get posted to the everyone channel?
Yes. Here's the first link. Here is the second link. Let me pull these so I can put them in the recording email too. Anybody else have questions, comments?
Have you parsed call detail records with this method or a Celebrite CSV for phone logs? I have not called detail records. So the way Log2Timeline works, Log2Timeline has specific parsers inside of it that it runs. So I would look to see if there are any parsers for the problem with call detail records is you have multiple formats and multiple ways those detail records can exist. So there probably isn't a parser just for that. There might be. I haven't checked, but Log2Timeline may have some kind of Celebrite parser, but you'd have to research log. This is a question I would definitely ask ChatGPT or Claude to see if it can research for you and figure out if it has parsers for that stuff. Is the Docker image any faster or slower than running it into a VM, running inside a VM, sorry. So you shouldn't see any performance degradation, but there are definitely optimizations because when you install Docker Desktop or when you install Docker and when you run images, you can define how much resources Docker has access to run containers. So there's some optimization and some configuration you have to kind of research and think about when you're doing it, because you could tell Log2Timeline there are some parameters you can pass into Log2Timeline that tells it how many processors to use and things like that. But you have to synchronize that up with the amount of resources that you've allocated to Docker itself too. But theoretically, there shouldn't be any degradation in performance because Docker is just a layer running on your host architecture. So it has access to all of your CPU, all of your memory. It's just a matter of what settings or configuration you get into Docker so that it knows what resources it has access to. Is there a limitation on how many processors can be utilized for processing information? What do you feel is the golden number for speed? That's a great question. That's another thing that's really cool about this. You theoretically can run these Docker containers. You can run these Docker commands for Log2Timeline. You can run multiples of them in parallel. So it's really, again, this goes back to Billy's question about resource usage, where it's one of those things where I would say just test it, because theoretically you could run 5 Docker containers of Log2Timeline simultaneously as long as you have the compute resources for it, and they can run in parallel parsing different images. The tricky part though is you just have to make sure that when you're running each of those commands that the volume mounting and everything lines up correctly. So you just have to make sure that the commands are pointing to the right files that you want. You can have one input folder that has all your artifacts and then run different Docker log2timeline commands to parse different forensic files in that location in parallel if you want. But there's also a way to parallelize log2timeline as well, where you can give it multiple parsers so that it can actually parse files in parallel in just one process. So that's something I would definitely do some research on, some R&D, and figure out what the best strategy is. My guess would be the best strategy is to just run log2timeline in such a way that it's using multiple processors and it just runs one log2timeline process that just parallel processes multiple files at once, because that's a little bit easier to manage. Um, yeah, that's what's so cool about this. There's just a lot of like, it's one of those tools that's very, very, you know, it's very close to the metal, as I would say. So there's lots of ways to kind of use it to your advantage, where you get to use it how you want, as opposed to like some of the off-the-shelf tools that we use. They just kind of come pre-baked. They just run how they run, and you don't necessarily have a lot of options around it. With something like Log2Timeline, you have a lot of control over exactly how it's doing things. Like you can control exactly what parsers it wants to use. You can control what files you want it to parse. You can control how much in resources it uses. You can control whether it runs a single process or if it runs things in parallel. You can run multiple Log2Timeline instances at the same time. Like you have all these different options at your disposal to really control your processing pipeline. So I definitely, if you're not having this as a tool in your tool set, I definitely recommend using it. All right, cool. Um, looks like we've exhausted all of our questions, I think.
Seems like it. Well, thank you everybody for coming today. We'll be sure to get the recording and those docs that Matt put together and the links that he put together in the recording email in a day or so. Otherwise, we hope to see you guys in 2 weeks at the next workshop Wednesday session.
Cool.
Uh,
All right, thanks everybody.